Imagine Earth as a giant, warm battery. Deep inside, it's incredibly hot. This hidden heat is a powerful energy source, always working beneath our feet. Sometimes this energy bursts out for us to see, like Old Faithful Geyser in Yellowstone, shooting steam high into the sky. That's geothermal energy in action, a peek at Earth's inner heat. Volcanoes are another dramatic example, showing the fiery power below us. But we don't need volcanoes in our backyard to use this energy. Scientists have found safe, clever ways to tap into Earth's heat. With smart engineering, we can harness this power gently and usefully. This hidden power is called geothermal energy. Geo means Earth, thermal means heat. So, geothermal energy simply means Earth heat, a natural, powerful energy source. Let's explore how it works and why it matters. We'll discover how we can use it for our homes and cities. Get ready for a journey to the center of energy. The adventure starts right beneath your feet. Let's unlock the secrets of our planet's own power plant. Where does all this Earth heat come from? Much of it has been here since Earth first formed. Billions of years ago, our planet was a spinning ball of molten rock. This leftover warmth is called primordial heat. Even though Earth's surface cooled, the inside stayed incredibly hot, like a baked potato that's cool outside but steaming inside. Earth's core is as hot as the surface of the sun. There's another source. Radioactive elements deep inside break down and release heat, like a slow, steady furnace. So, Earth's heat comes from both its fiery birth and ongoing processes. Geothermal energy is this internal heat, and we can use it in many ways. It warms homes, heats greenhouses, and even generates electricity. This is a clean, reliable gift from our planet. Geothermal energy is sustainable and always available. Let's find out how we can put this ancient heat to work. The possibilities are exciting and important for our future. Ready to see how we use Earth's warmth? If Earth is hot everywhere inside, why don't all countries use geothermal energy? The answer: it's much easier to reach in certain places, called geothermal hotspots. These are areas where heat is closer to the surface, making it practical and affordable to use. Hotspots are often found near tectonic plate edges, giant puzzle pieces that make up Earth's crust. Where plates meet, magma rises closer to the surface, creating more accessible heat. That's why countries like Iceland, New Zealand, and parts of the US have lots of geothermal activity. Iceland, for example, uses geothermal energy for most of its heating, even swimming pools. These countries lead the way in using Earth's heat. But new technology is helping other places join in. We're learning to reach heat even where it's not obvious. More places can now tap into geothermal energy. The geothermal party is growing worldwide. It's all about finding and using the best spots. With innovation, more regions can benefit from this clean power. The future is heating up everywhere. How do we turn Earth's heat into electricity? We need special geothermal power plants. These plants transform raw heat into the electricity we use every day. Nature gives us geothermal resources in different forms: steam, hot water, or just warm water. Engineers have designed three main types of geothermal power plants for these conditions. First, dry steam power plants, which use underground pockets of pure steam. Second, flash steam power plants for superhot underground water. Third, binary cycle power plants, which work with lower temperatures. Each type is suited for different underground resources. These technologies help us make the most of what Earth offers. Let's take a closer look at how each one works. They all use Earth's heat in clever ways to power our lives. Real-life science is making a big difference. Geothermal energy is a key part of our clean energy future. Let's dive into the details of these amazing plants. First up, dry steam power plants, the oldest type. Imagine a natural kettle underground, filled with pure steam. The steam shoots up through pipes to the surface, spinning a turbine to make electricity. The geysers in California is a famous example of this technology. Next, flash steam power plants, the most common today. These use superhot underground water under high pressure. When brought to the surface, the pressure drops, and some water instantly flashes into steam. This steam spins a turbine, generating electricity. Many plants in Iceland and the Philippines use this method. Both types rely on Earth's natural heat and pressure. They show how we can directly turn underground energy into power. It's a clean, efficient process. Geothermal plants are powerful examples of working with nature. Now, what if the water isn't hot enough for steam? That's where the next technology comes in. Let's see how we use gentler heat for big results. The story of geothermal innovation continues. What if the underground water isn't hot enough for steam? Enter binary cycle power plants. These clever plants use much cooler water, sometimes as low as 100 degrees C. The geothermal water never touches the turbine. Instead, it heats a special working fluid with a low boiling point. This fluid boils easily, turning into vapor that spins the turbine. The process happens in a heat exchanger, transferring warmth from Earth's water to the working fluid. The vapor expands, spins the turbine, and generates electricity. It's an indirect but highly efficient method. Binary plants can work in more places, not just rare hotspots. This technology expands geothermal's reach worldwide. More regions can now use Earth's gentle warmth for power. Binary cycle plants are growing in popularity. They unlock new frontiers for clean energy. Geothermal innovation is opening doors everywhere. The possibilities are bigger than ever. How does deep earth heat become electricity in your home? It starts with scientists exploring and testing the ground for underground heat. Once a good spot is found, deep wells are drilled, sometimes miles down. Hot water or steam is brought up through production wells. This heat is piped to the power plant, where the real magic happens. Steam or vapor spins a turbine, which is connected to a generator. The generator converts spinning motion into electricity. Afterward, the used water or steam is pumped back underground through reinjection wells. This process, called reinjection, recharges the geothermal reservoir. It's a closed loop, sustainable and environmentally friendly. Modern geothermal plants are designed for efficiency and minimal waste. The whole process is clean, reliable, and renewable. Geothermal energy is a model for sustainable power. It's science and nature working together. That's how Earth's heat lights up our world. Geothermal energy is like a treasure chest of benefits for our planet. It's renewable. Earth's core will stay hot for billions of years. That means clean energy for generations to come. Geothermal is reliable and consistent. Unlike solar or wind, it provides steady, round-the-clock power, perfect for baseload electricity. Power plants have a small land footprint, leaving more space for nature. They produce very little greenhouse gas, helping fight climate change. Geothermal plants create almost no waste. Used water is returned underground. No big piles of ash or harmful byproducts. It's a powerful way to tackle global warming. Geothermal energy keeps our air clean and our planet healthy. It's a smart green choice for the future. The benefits go beyond just electricity. They help our whole environment. Geothermal is a gift from the Earth, ready for us to use wisely. Clean, reliable, and sustainable. What more could we ask for? Let's keep unlocking this amazing energy. Geothermal energy is amazing, but it has challenges. Drilling deep wells is expensive and requires skilled workers. High upfront costs can make projects hard to start. Finding the right spot is tricky. Hot rocks must be close to the surface and have water. Not every region has these ideal conditions. This limits where traditional geothermal plants can be built. There's financial risk. Sometimes, after spending money, not enough heat is found. It's like a costly treasure hunt with no guarantees. Some geothermal water contains gases like hydrogen sulfide, which must be managed carefully. Modern plants capture these gases to protect the air. Some systems need a lot of water, which can be a problem in dry areas. Water management is crucial for sustainable operation. These challenges slow down new projects. But with innovation, many obstacles can be overcome. Geothermal's future depends on smart solutions. The good news: scientists and engineers are solving geothermal's challenges. Enhanced geothermal systems, EGS, are a game-changer, creating man-made reservoirs almost anywhere. EGS could bring geothermal power to places without natural hotspots. It involves drilling into hot, dry rock and pumping water to create a reservoir. The water heats up and is brought back to the surface for power. This revolutionary method expands geothermal's reach. New drilling techniques are lowering costs and speeding up projects. We're also finding ways to use lower temperature heat more efficiently. Every innovation helps geothermal energy grow. Geothermal is a steady, clean partner in our energy future. By unlocking more of Earth's hidden power, we can light up our world sustainably. The future of energy is bright and warm from deep below our feet. Let's keep exploring and innovating with geothermal energy.